Welcome everyone to the exercise on dual graphs and planarity. Your task was to check if two given graphs are planar, and if so, if they're also maximal planar. Okay, so let's start with the first graph. We can see here 6 nodes and different connecting edges. And the hint was simply to start with drawing the nodes and try to connect them without crossing the edges. So this is the definition of planar graphs. So they cannot have crossing edges in the graph. So is it possible to draw this particular graph in such a way that all the edges are not crossing each other? And so, for instance, the edge between node 1 and 6 is crossing, is crossing the other, so we delete that one, and we can use and connect it from outside. Okay, so that's fine. However, we have still a crossing between the node 4,3 and 5,2. Okay, let's also delete this one then. Okay, so therefore we don't have a crossing anymore, but we still have to connect node 1, 2 and 5. So we could go from this side, okay, but at one point you have to cross the edge between 1 and 6, or you go the other way around, okay, and you also have to cross it at one point. So therefore this is not a planar graph. Okay, so this is not possible to draw it in such a way that the edges are not crossing each other. Okay, then let's have a look at the second graph. Okay, is this first of all planar? So again we have some crossing edges. So for instance, the edge between 3 and 4. Okay, what we could do is to or let's do it the other way around. Let's maybe have this look with delete this one between 1 and 2. What we can do is simply to connect it again from outside. Okay, so we still have an edge that is crossing the others, so we also delete 1 and 6. Okay, so the edge between 1 and 6, and we can also connect that from the outside. So everything is fine. We avoided the crossing, and now we have a planar graph where the edges are not crossing each other. So therefore we can say this is a planar graph because we don't have any crossing of the edges. And the next question is if this is maximal planar. So we know if this is a maximal planar graph, then it's also automatically also a deltahedron. And we remember from the lecture that in this case the following relation holds. So the number of edges is 3 times the number of nodes minus 6, which is in our case we have 6 nodes minus 6, so that means we would need 12 edges. Okay, however, if you count that, we currently have a graph that has only 10 edges. Okay, so that means it cannot be a maximal graph, it cannot be a deltahedron anymore. Okay, because otherwise this relation would hold. We would need 12 edges. And if you look at the graph, you can see that if you connect nodes 1 and 3, okay, you could add an edge without crossing the others. Okay, and therefore this is not a maximal. It's not a maximal planar graph. Okay, if it would be a maximal planar graph, then you wouldn't be able to add an edge without crossing the others. Okay, but here you could, And this is also shown by this simple calculation of the number of edges that is not fulfilled here. So this is not a maximal graph. Okay. Okay, let's proceed to B. So you have this graph and you should determine the dual for this primal graph, and you also remember from the lecture how to determine that one. So first of all, we have to understand which are the inner facets and which are the outer facets of this primal original graph, and for each inner and outer facet you need a node. Okay, so you remember that an inner facet means simply that you have some kind of elementary circle, meaning that the nodes and edges form some kind of closed loop, and they don't share any common area together. Okay, so in our case, what is here the inner facet in this particular example? So the inner facet here would be just the triangle here 1 4 4 2 and 1 2. Okay, so this is 1 2 and 4. This is inner facet, and the outer facet, this is simply what is formed by the others, so meaning basically that is not covered by inner facet. Okay, so it lies outside the entire boundary and formed by all the vertices and all the edges and nodes. Okay, so that means simply, so the outer facet is all these nodes. They form this outer boundary. Okay, 1 2 3 and 4. Okay, so that means we have two facets. That means we need two nodes. So for the inner facet 1 2 4, we say this is then node A in the dual, and for the outer facet we use the node B. Okay, and the next step is to add one edge for connecting these two facets. Okay, and you should remember we need as many edges as in the primal version. Okay, so in the primal, in the original graph, we have 4 connections, 4 edges, and this should also be the case in the dual. So that means edge 1 2, this one as 1 and 2, this one, this edge is shared by our node A, but also by node B. Okay, so this should be connected. Okay, 2 and 4 is part of A and B. Okay, so this edge is shared by both nodes. Okay, so we have to connect that one. And the edge 1 4 is also shared by A and B. Okay, however, the edge 1 3 is only part of the node B, so it's simply connected by itself. Okay, and therefore we have now a dual representation. We have 2 nodes and still 4 edges connecting these 2 facets. Okay, and the last one, this looks like that, and we again have to understand which are the inner facet and which are the outer facet, and for this case it's pretty easy and straightforward. So this is one facet, so let's call it A. This is one inner facet, 2 4 5, call it B. Then we have this inner facet, we need a representative node C, and then we have this inner facet. Okay, let's call it like D. So these are 4 inner facets, and then we have the outer facet containing all the nodes 1 2 3 4 5 6, and for this outer facet we also need one node for the dual representation. Okay, so let's call it E, and then we again have to connect them to each other. So for instance, maybe I can close that one. So so that means A and B, the edge 4 and 2, this one, okay, is shared by node A and B, so we can have a connection here. Okay, 1 and 4, the edge 1, 4 has is part of A and E, so we can connect the outer facet and the inner facet. The same for this one. So this is this edge 1, 2 is shared by A and the outer facet E, so that has to be connected. And that one, this 4, 5, this is shared by node B and E. Okay, and the same on the right hand side. So this one, then this is connected over here, this is connected over this edge. And of course C and D are also connected, and B and C as well. Okay, so that means we have as many edges in the dual as well as the primal graph. Okay, and with this I would like to thank you for your attention.